Hello and welcome to another video. Today we're going to be continuing on with the blind 75 and we're going to be doing insert interval in TypeScript. So in this you're given an array of non-overlapping intervals and they are sorted, and you want to insert one interval into them, and then if there are some overlaps you want to make sure you handle those. So in this first example we have this array 1, 3, and then we have 6, 9. I'm just going to draw it like this to make it a little bit easier. And so we need to put in 2, 5, and 2, 5 can actually just go straight in here, and there are no like overlaps or anything, right? It can just go straight in the middle. Okay, now let's go for the second example, and this is where we have some issues. So we are going to have 1, 2, and then we're going to have 3, 5, and 6, 7, 8, 10, and 12, 16. And now we are trying to put in 4, 8. So, like, let's just logically think of like where it would go without any kind of algorithm, right? Well, it's like if we look at 1, 2, it's obviously going to go after 1, 2. What about 3, 5? So it actually does overlap with 3, 5. And so for any two intervals that overlap, like if 4, 8 and 3, 5 overlap, we are just going to merge those. And remember, to merge two intervals, you just take the smallest value on the left and the biggest value on the right. In the previous problem, the smallest value on the left was always the one on the left, but now it's not guaranteed, right? So you can see like this 3 is actually smaller than this 4. So the way to merge this is you take the smallest value from the ones on the left and the biggest value from the ones on the right, so we'd merge those into that. So 4, 8 and 3, 5 would now become 3, 8. And so we'd throw that in here. But now we have another problem that 3, 8 and 6, 7 are also overlapping. And so we're going to need to merge 3, 8 and 6, 7. And how do we do that? Well, we need to merge them again. So same thing, smallest one on the left, biggest one on the right. So now this 6, 7, as you can see, perfectly fits in 3, 8. So we can just say 3, 8 can go here. We'll just get rid of 6, 7 because our merge interval will just be 3, 8. But now 3, 8 and 8, 10 are also overlapping because, yeah, these can't be the same. So now you merge those, and that would be 3, 10. Same thing. Biggest value on the right and smallest value on the left. So 3, 8 and 8, 10 would actually combine to be 3, 10. And then finally, 3, 10 and 12, 16 are not overlapping. So then our solution is 1, 2, 3, 10, 12, 16, as you can see here. So we're going to focus on that solution. We're going to go back. And we are going to, like, this was kind of like how you do it intuitively, but how do you do this in an algorithm? And it's going to be reasonably straightforward, but we're going to want to have a result. So let's just change the color here. So we're going to have a result array. And we are going to have the interval we are trying to insert, which will just be, we can actually probably just get rid of this like problem description for now. I don't think we're going to need it. So we're going to get rid of that, and we are going to put in 4, 8 that we are trying to insert. So this is like our current interval that we were trying to insert. And essentially, we're going to have a few cases. And we can even write those down. So case 1, we're going to be on some current interval. So if insert interval is just greater than current interval, then we will just insert cur interval and move on. Other case, if insert interval is less than cur interval, then we can actually just insert cur interval, or sorry, we will do insert interval, right? This one that we're trying to insert interval. And then we can just insert the rest of it. So for example, if we had something like, let's see where there is no overlap. Let's say we had like, let's just say we had like 0, 0, for example, right? So we're trying to insert 0, 0. So if we try to insert 0, 0, we are going to go through this array, but like we'd be on this element. We'd say, okay, 0, 0 is actually just less than this, right? It's not overlapping, it's just less. So then we can just put 0, 0 into our result. And once we actually inserted the thing we need, everything else, there are no conflicts. So as long as like the current thing we have, if we can insert it cleanly, everything else, there are no conflicts. So then we can just copy in the rest of this array. So all of this can just go in here and then we're done. So that's like a slight optimization here, where if the insert interval is just less, we just insert and then we just insert the rest of it. And insert all elements left. And then finally, if we have a conflict, right, if they overlap, then merge and save value and continue. Right? So if they do overlap, we're just going to merge, but we can't really insert it right away because there might be another conflict. Okay, so let's go through this with this solution and with these 3 steps, and let's show what that's going to look like. I'm actually going to delete this, put this over here. Okay, so we are trying to insert 4.8. That's the value we are trying to put in. We'll just have this. And then we are currently on 1.2. So which one of cases is this? So 1.2 and 4.8. So this insert interval is actually just strictly bigger, right? And obviously, how do you check that? Well, you know that like this value will be less than or equal to this value. So you can just check like if this value is bigger than this value over here, that means it's strictly bigger, right? So pretty straightforward. So this one's strictly bigger. So then we can just insert this interval here, and we can save our interval to be inserted later on. So we can just put 1.2 in here, and now we will move on to 3.5. Okay, so what about 4.8 and 3.5? So 4.8 and 3.5, which one of these is it? Well, they actually have a conflict, right? They are overlapping. So then what we need to do is we need to merge 4.8 and 3.5. So we're actually going to merge those into, that will be 3.8, right? You take the smallest value on the left and the biggest value on the right. Okay. And remember, we can't just insert it yet because there might be conflicts farther down. So now we are over here. And now which one is it? There's a conflict again. 6, 7, and 3.8 are overlapping. So we merge those, and remember, they would just merge into 3.8 because 6, 7 is actually just fully in 3.8. Right? So to merge, smallest value on the left, let's actually write that down. So to merge, new interval equals min of left and max of right value, right? So whatever they are, so min of the left is min of 3 and 6, which is 3, and then the max of 8 and 7, which is 8. Okay. So now this is our current interval. Now we go over here, and now which one is that? There is a conflict again, right? So 3.8 and 8.10, we need to merge those. So once we merge 3.8 and 8.10, we are going to get 3.10. Okay, now we're on the last value. And now our value that we're trying to put in is smaller. So insert interval is this one here. So then we can insert it, 3.10, and then finally we insert everything left. Now there is another thing. There is another case that you have to handle. And that's if, like, let's say there's just merge conflicts the whole way. Or let's just say we got rid of this value. So let's say this value wasn't here. Okay. And so in that case, you would go through everything, and then your interval would be 3.10. But you didn't actually insert it, right? We went through all of these, and then we would still have this interval that we need to try to insert. So if we still have an interval we need to insert, at the very end, once we're done with that loop, we need to insert it and then return. So in that case, like, we wouldn't have these at all. And then we'd be done with this, and our interval would still be 3.10. So then we'd have to put in 3.10 after we're done with the loop. But that's essentially it. So we can write that down as well. So if we still have an interval at the end, insert it. And we always will. Otherwise, we're just going to return, because here we can just return straight away, right? Like if the interval is less than the current interval, like let's say it was at 0, 0, you can just put in 0, 0, put in the rest, and then just return. But for every other case, it means you had a merge conflict at the very end, right? So, or alternatively, it also means that the interval is bigger than all of them. Like, let's say your interval is like 35, 80 or something. Then it would just be bigger than this, bigger than this, bigger than this, bigger than this, and then finally you're out of bounds. So either way, that means your interval needs to be at the end of it. Okay, so that's that, and now let's code it up. So we are going to have a result, so we can just say const result, and it's going to be a two-dimensional number array. Set it equal to an empty array, and like I said, you want to give it a type if you make it equal to an empty array, because this can be anything, right? It can be a string array, like it's defined. It would probably give you a warning that it's like defined as any. Okay, now we need to loop through our intervals. So for let I equals 0, I is less than intervals length, I plus plus. Then we will destructure our new interval and our interval just to make it easier to work with. So we can just say const insert first. I guess maybe since it's JS, you probably want to use camel. So insert first, insert last, equals new interval. So we're going to destructure it, and then we're also going to destructure the current interval we are on. First, last, And we don't need to give it types because these will be set to numbers, so it'll know that they are numbers. Okay, and now we have a few cases, right? So remember, what are our cases? So if insert last is greater than first, or sorry, if insert last is less than first, right? So if this is the case, if insert last is less than first, this means that like the interval we are trying to insert is less than the current interval we are on. That means we can just insert directly and then insert everything else at the end, right? That's this case here. That's this case over here. So this is number 2. Okay. So if that's the case, we are just going to simply return an array of everything. So we're going to say, let's just take result. Let's add the new interval. And then finally, let's add the rest of it, which will be intervals.slice from the current index, right? So that will give you the result, the new interval put in, and then every interval from here on in can just be put in, and then we're done. Okay, what's our other cases? So if insert first, this is the one that our interval is actually greater than the current interval we are on. So if the interval is greater than the current interval we are on, we can just push that to the result. So we can just push the current one to the result, intervals I, and then we can move on, right? So that's, if you look in this picture, that's this case here, insert the current interval and move on. And then finally, we have that merge conflict. So for the merge conflict, we will have new interval equals, and remember, you take the minimum value on the left, so we can just do math.min first, insert first, and then it's going to be math.max, and this is a camel, of the right. So last, insert last. Okay, and we should have everything we need here now. So yeah. I think destructuring makes it a little easier so you don't use like intervals I0 and stuff like that. It makes it a little, maybe the names aren't great, but you can make them better names. Okay, and then finally we need to do a couple more things that I forgot. So we need to push the interval if we haven't returned yet, because we should always be pushing it, because that means the interval is either at the end or there's merge conflicts. And then finally we need to return the result. So if you didn't do this case, that means that you are going to have an interval in here somewhere. Okay, and let's do that. Let's see what we get. Okay. Okay, and once again, TypeScript is super weird. I write the same code, I don't know why, multiple times, and I get like super different results, which is kind of strange. So yeah, don't really know why that is. See, it's like all over the place, so whatever. Okay, so let's do the time and space complexity here. So for the time, Python, it's going to be O of n, right? Because we're essentially looping through the intervals one time. We are doing some slicing, and you maybe can make it a little bit faster by not slicing, but it doesn't really matter. We're only slicing once. We're only copying this once. It doesn't really make a difference in time complexity. But essentially, this is O of n. It's one loop. Okay, and then for the space, we do have a result, and we do have this interval, but this interval is only an array of length 2, so that doesn't really cost us anything. And actually, technically, it is an input, so yeah. If you didn't want to modify the input, you could do something else, but yeah, you could just like make a copy, I guess. That would be pretty easy. Okay, anyway, so the space is going to be O of 1 here. And yeah, that's going to be it for this problem. Hopefully you liked it, and if you did, please like the video, and I'll see you in the next TypeScript problem probably tomorrow. So thanks for watching.